Hello, class. I'm gonna have a crazy day tomorrow. I've got lots of meetings to go to. That's what it means to be and work in America. And the year 2024 is sit in front of a computer and go to meetings. So that's what I do as well, mostly. So I thought I'd go ahead and make this video tonight. And you can probably see that it's Wednesday at 9:20 p.m. So I'll make the video and edit it down and send it out tomorrow. Maybe I can do that while I'm in my meetings. Why not do two things at once, right? So, but I don't think I could talk like this and make a video in my meetings. That might be a little weird. But I wanted to show you this article. It's a recent article on batteries. So, specifically lithium ion batteries, and lithium ion are used very frequently as a rechargeable battery. We have a couple different types of rechargeable batteries. So the lead acid batteries, that's typically what a car battery is, like the ones in most cars. It's a lead acid battery. Those are rechargeable. And their nickel cadmium is one, nickel metal hydride is another one, and one of the more common ones that we see quite a bit are lithium ion batteries. Why are they used and why are they so useful? Well, among other things, they're light. So that's the battery that's in cell phones, for instance, and this laptop and my iPad. All my fun toys. They have lithium ion batteries in them, and used quite a bit in electric and hybrid vehicles as well. Same idea, lots of energy density, relatively lightweight. So what do I mean by energy density? Well, what's gonna cause you to gain more weight? Like if you ate a big plate full of broccoli or a big plate full of chocolate or like a big plate full of butter, right? You're like, what's gonna cause you to put on some weight? And the answer is like not the broccoli, but the chocolate and or the butter. I mean, I don't know if you'd want to eat a big plate full of butter, but um, that will cause you to gain more weight. Why does it cause you to gain more weight? Because there's more calories. What does it mean to have more calories? It has more energy. So energy density right there. So if you can understand energy density, there's more energy in a big plate full of butter, a big plate full of chocolate than there is in a big plate full of something like broccoli, right? So that's energy density. Same thing with batteries. And one of the things that's nice about lithium ion batteries is they're light and they're jam-packed full of energy. So those are good things. Some of the problems with batteries is the environmental damage. So when you make them, you have to mine materials for them, and specifically some things like cobalt, and and there's quite a bit of environmental damage in mining because so you disturb the soil. So when you mine, you disturb the ground, and then rainwaters come, and it's actually pyrite, fool's gold, iron sulfide. The rainwater comes, and typically pyrite then that dissolves, and you get acidic. It acidifies waterways, and not only that, also in processing the ores. So we take ores and we turn them into metals, and processing the ores also causes environmental damage. So why not, instead of using these metals, what if we used an organic molecule like this one here? So these molecules here. So it is tetraaminobenzoquinone molecules. Say that 3 times fast. And they're connected to each other with strong hydrogen bonds. So these molecules it looks like they can replace the metals as a cathode. So that's good. That's good news. So I mean, this is that means we can synthesize these molecules without the need of the added environmental damage and energy production that's used in mining. So and they've run these things for several cycles. Where let's say here, 2,000 charge cycles still has quite a bit of energy in them, and hopefully it'll still work. So Where are we at right now? So this is still in the science phase. We haven't quite gotten to. I mean, we've got an application for it, but I mean, is it gonna actually gonna work? I personally am a little skeptical. I hope it works. I absolutely hope it works. But a problem I could see with this is overcharging. So one of the things with lithium-ion batteries, and I personally try to be as diligent as I can. The absolute worst thing you can do with a lithium-ion battery is you can overcharge it. Meaning, when you come in, you just plug it in, and you see it's 100%. Like, I'll just keep it plugged in at 100%. What's the harm in that? The harm in that is that you're putting a lot of electromotive force into this battery system. And what happens when you put a lot of electromotive force into a battery that's already charged is that the lithium ion, the lithium plus, can be reduced to form lithium metal. And then that lithium metal then can attack and damage the battery. So if you wonder why your lithium ion batteries degrade over time, that is typically the reason why. It's because when you're charging it, there's other things you can do, right? You can drop it and it can crack. I mean, various other things, just corrosion. But the main cause for lithium-ion batteries to lose their performance over time is the fact that from overcharging, you form lithium metal, and lithium metal is very reactive, and that destroys the components inside the batteries. Quite frequently, it's the electrolytes. It's like the transport across the gels. So like the lithium ions, they go back and forth from the anode and the cathode through a gel. Usually, it's damaging the gel. And I'm looking at this molecule. It's an organic molecule, meaning it's carbon containing. So it's a carbon containing molecule. And the chemist in me looks at this, and I think this would react very strongly to lithium metal. So I can see a possible issue with this being from users that overcharge the batteries could see a performance drop very quickly. And that's just my opinion, and that's a hypothesis. But hopefully I'm wrong. Hopefully I'm wrong, or maybe they'll put in a program to stop the charging, like when it's at 98% or something like that. So hopefully this will change your habits. So when don't ever really charge your batteries over 100%. So it's better to keep them a little bit below that. If you're charging up and you see it at like 96%, when I'm charging my phone, I see it at 96%, I unplug it because I don't want those lithium ions to turn into lithium metal and to destroy the battery. So, okay, well, hopefully you've learned something, and hopefully you see okay, we're working on new batteries, and we're just going to test this more. And then maybe it'll go out in a car or something else, or maybe a cell phone. I don't know. And hopefully it'll be safe. So we don't know. So, but chemistry is a very broad topic and includes things like batteries. And of course, we use batteries quite a bit. So I thought it was an interesting article, and it also ties into how we get materials in the mining, and also sustainability, how we are trying to move away from practices that are less sustainable to hopefully find practices that are more sustainable. And every little bit helps. And also economically, this has got to be cheaper. It'll bring the price down. So if it works, this is great. I really hope it works. So we'll see. And as always, I hope you're doing well. If you're not doing well, if you're finding your basic needs not being met, if you're having any other academic issues, of course, this is my course. If you're having issues with my course, come to me. If you have other academic issues, let me know, and I'll see what I can do to help. And if you're having mental health issues or other issues, whatever it is, if you need help, I want you to succeed. You want to succeed, so let's work together, see what we can do to keep you on track and on to graduate and go out. So, okay, I'm going to sign off for now. So, aloha. Have a nice weekend.